Thank you, Krishni, for this warm introduction. It's a great pleasure to present again my research in this webinar. Today, I will talk about using waste as a resource. So I will talk about mainly sediment, but also in Sludge for one application. So as Krishna said, my university is Normandy. University is northwest France. There are 70,000 students in this university, 2,300 researchers. It includes 3 sites, Caen, Rouen, and Le Havre. So I am working in the site of Le Havre. My research topics are focused on geoenvironmental engineering. I started by investigating the mass transfer in porous media, also pollution transfer. So as application, I also investigated the internal erosion and the scour around the piles. I used also recently, I started to use with my colleagues in the lab ultrasonics for characterization of solid suspension. We see that can be an application for the concept of sailing depth with the rheological investigation of sediments. For remediation of polluted soil and sediments, I used since more than a decade electrokinetic remediation for soil and sediment. And also I used the rheology of mud and suspension to investigate how we can just leave the sediments in the seabed, and when removing the sediments, sailing or chipping can be really saved. Okay, yeah. Since we are in this area of maritime port, Le Havre is the first maritime port in France. So many huge volumes of sediments are annually dredged. So in Europe, there are 200 million cubic meter sediments which are dredged each year, and in France, 55 millions of cubic meter are dredged, of which 24 millions are contaminated. So this contamination have to be treated, and we use the electrochemical technology to start remediating or try remediating this material. So these volumes are expected to increase up to 70 million cubic meter in the next 10 years. So in Le Havre, the silting of sediments is a huge issue, and in many operations, the port was going to dredge sediments and clapping or dumping it very far from the location or the dredging location. So the cost can be more important. So dredged volumes over Europe, so we can on this in this graph that in Belgium was the country where the most volumes of sediments are dredged. And in France, we see the evolution, the increase of these volumes during recent years. In 2009, because there was the management of new port in Le Havre. So that's why the dredged volumes were increasing at 2009. So how that sediments are managed? 90% of these volumes are dumped in sea, so but submitted to regulations. Threshold values of pollutants are defined by European regulation, but which were adopted to local or national regulations, which define the allowed volume to be dumped in sea. In France, almost 30 million cubic meter are dredged are dumped. So the substrate modification, water turbidity, increased marine life threatened was some issues which can be avoided if the sediments are deposited inland. So the deposit inlands are a special operation, and there's no permitted every time. So in Le Havre, for example, there was only 2 deposits for these sediments. As regards to regulation in Europe, we see that the regulations are very, very heterogeneous. So we see that, for example, for chromium, you see the limitation are maybe four times higher in many countries than others. So that's why many volumes of sediments can move from a country to another. These sediments are not so polluted because, as regards to the regulations of sludge use inland or standard amendments of soil, there is only the cadmium which exceeds the standard values, the limited values. So, but in France there is regulations, national regulations about soil, but there is no regulations about sediment. Sediment are regulated only about how many cubic meters or each volume can be clubbed in sea, regarding 2 levels, in 1 and in 2. So in last project we have to show how was the variability of these sediments over a large area, including Port of Le Havre, the Seine River, and also a part of Rouen Port. So 10 samples were collected, and we see from the analysis of grain size that mainly the extent of the grain size is not so different, only for three samples. Also, the carbonates are quite similar, around 20%, and organic matter is also similar in different ways, approaching 5%. So this kind of investigation can show that this sediment can be used for any application, because we can expect regular characteristics for this material. So this variability is also very low in chemicals and in minerals. So it can be interesting to use this sediment from a large area in Normandy. As regard to the levels, the two levels in one and in two, which were the regulations for dumping sediments in sea. Yeah, in many situations, these limitations were exceeded, so not so much. So for in the objective of using this sediment and keeping it in inland and maybe using it for valorization for the reuse, two deposits were managed in Le Havre. The largest one is close to Tancarville, close to this bridge. So there is 60,000 cubic meter deposited, sediment deposited here, and this area. So for the sediment which was deposited, there is no excess of any metals, only for cadmium, which exceeds only by 0.2. So it's not so important. And this area was immediately that's the time for filling the deposit, and 2 years after later, so the vegetation start to grow in this area. That shows that the sediment can serve as agricultural soil, as a medium enabling growing vegetation. And 10 years ago, we see that it's a forest, almost a forest. The objectives of land deposit was to dewatering and salinity lowering. So if we see in this diagram for this first deposit between 2009 and 2018, the moisture was decreased from 120 to almost 20%, and the salinity also decreased from 40 to 4, 10 times, but the organic matter increases. So this kind of deposit can be interesting for reuse in agriculture or in material constructions. But the pollutant bioavailability is still there, so they maybe for many applications they need to be remediated. The second deposit was managed during the project making bricks from dredged sediments, and this deposit was managed in other way than the first one, with drainage and with settling chamber. So this deposit was monitored during many years, from 2019 to 2020, and we see that the conductivity, the salinity decreased in 3 points recorded here. We see that the salinity decreased from 9 to almost 3, so 3 times only in 11 months. Okay, so when the polluted exceed regulatory values, so we need remediation. In our university, we started using electrochemical remediation because we are treating fine soil, fine material. So electrochemical remediation is deemed to be effective for this kind of material. So we started by a small cell, and then we and then we used a large setup with many many kilograms of 60 kilograms of material in order to mainly use this sediment in another project, but also in investigating the scale effect, the upscaling effect between the small setup to the intermediate setup before using a field pilot. The objective of sustainable electrokinetic remediation was to decrease chemical concentrations, dewatering the material, enhancing element bioavailability, using friendly environmental additives, and reducing treatment costs by using less power consumption. Here there is the schematic drawn schematic of the setup, and we have here different additives used in many experiments, showing that EDDs and subprime, which are the surfactants. The surfactant can be also efficient for making the osmotic flow interesting, and so removing many kind of pollutants. So because we can treat different kind of sedimented soils, we investigate the effect of organic matter in different remediation tests. So we compare the application of EKR to reconstituted lab sediment and the collected sediment. The reconstituted sediment in lab was made according to the grain size distribution of the real sediment. It's a mixture of sand, silt, and clay, and we add 5% of organic matter. So in this case, the metals, mainly the metals, which are here two metals, copper and zinc, which are moving accordingly to the charge. So here we see that with acidic citric as additive, the lead move to the cathode, toward the cathode. So the organic matter can influence the electrochemical environment by buffering pH change and modifying redox condition, which can further promote metal solubilization in the anodic region, and the organic matter can prevent metal precipitation and reabsorption during transport, and then improving remediation efficiency. But when we test dredged sediments from a deposit, which involve an organic matter of 10 to 11%, we see that something happened, that the metals, many metals can move. The cation can move to the anode instead to move to the cathode. So this this disturbance is due to the content, relatively high content of organic matter. So organic matter can play a role in the electrokinetic accumulation process. And after that, we used many size of experiments to start investigating the upscaling of this process in order to use it in field. But we are still investigating this because the theory of upscaling is different from the other fields like hydraulics. So we started by using the bulk density as a parameter to be preserved from a scale to another one, the current density, temperature, and geometry. So when we increase the volume of treated sediment, the temperature rise and the process was inhibited. So for using dredged sediments as a material for making soil or making construction materials, we started with this case of using sediment as a waste for reconstructing soil, degraded soils. This is an European project which was ended in 2021. Why sediment can be interesting for soil reconstruction? Because the sediments which were investigated in this in the area of Normandy ports, they are rich in fines, 92%, around 6% of clay, and also rich in organic matter and other minerals. So they can be suitable to reconstruct soil. In this project, we suggested from our side the dredged sediment to be added to degraded soil in Brittany to make growing zucchini. And other partners from Geological Bureau in Orléans, they suggested the fines from the byproducts from the colors to be used also to as amendment for degraded soil, which were poor in fines. So this operation can be made in the large framework of anthropization of the cycle soil sediment soil. So because sediments are eroded from the soil, they are going to the rivers and the channels. So they are dredged and they can be used for treating or for reconstructing or amending degraded soil or agricultural soil. So this operation can be interesting in the framework of using waste to be a resource. The experimental setup for treating these sediments was in the same shape like in the smaller setup. We treated more than 60 kilograms of sediment to be used for reconstructing soil. So in this operation, we used non-treated sediment and electrokinetic treated sediment. So to see how electrokinetic process can change the soil, the composition of soil, and if there are any effect on this on growing vegetables or crops. So we had to check the processes in the sediment, where each processes happen in the sediment during treatment. What was about physical-chemical properties, pH, conductivity, index potential during the experiment, sediment after the experiment, mineralogy, total carbonates, organic matter, and metals. So after treatment, see that only the carbonate decreased. There is no change in the other parameters, especially in the elements like nitrogen, carbon, phosphorus, calcium, magnesium, and the selenium. So only the carbonates, because of oxidation in the anode parts, the carbonates were dissolved. A part of carbonate was dissolved following this reaction. So for this project of soil construction using waste like sediment, we used five samples. The first one with treated sediment, completely with treated sediment by electrokinetics. The second one, we add 3% of treated sediment to 70% of regular soil, degraded soil. The third one is not treated sediment, and the fourth one is 30% not treated sediments, and 70% regular soil. And the fifth one is the control sample. So the first sowing was made in March 22, and in all situations the zucchini grows, the crop grows, except for the completely non-treated sediment. For the non-treated sediment, the crop died after three months. So following that, in July, there was a second sowing in the same soils. So this time and for the completely non-treated sediment, so it was successful. The growing of crops was successful. We think because the irrigation make the salinity lowering, so maybe this can the effect that makes growing the crop in this second soil. And when we analyze the different samples, the 5 samples, as regards to the different metals, we see that in many situations, for many metals, we are exceeding the threshold value for excavated soil, but not so much. So this sediments, or this mixture of sediment and soil, are not so dangerous for use in agricultural soil or in landscaping. As we get to the metal accumulation, so when the vegetable or the crops grow, we analyze how the metals were moving from the sample for the soil to the to the crops, to the crops. Yeah. So we tested here two metals, copper and zinc, and we see that for in the matrix, in the soil matrix, sediment matrix, for example, for the treated sediment and added with soil, we reach 40 milligram per kilograms, while for the after growing in the plant, we don't reach 0.6. So the transfer between the soil matrix and the plant is very negligible. So we can say that the risk of contamination of plants is very low. So let's talk now about the valorization of sediment for construction material. The first construction material which was used were bricks, fired bricks. In that project we used many mixtures of sediment and clay. So we used till 100% of sediment to make bricks, and this product, this material was agree the standards of the material construction, because we exceed 9 megapascal as bending strength. So and this is adequate material for making bricks as regards to the strength, but adding sediment leads to increase water absorption when we exceed 30% of sediment, and also many degradation can appear, or white colorings because of salt contained in sediments can also affect the brick appearance. And the third use of sediment, or valorization of sediment, was the use for manufacturing lightweight aggregates. This project is ongoing. It was funded by European funds with a company which is involved in this project, which is leading this project. So they constructed a pilot for firing these aggregates to be used in lightweight concrete, or as landfill, or as lightweight materials, or also as isolating material. So the Dredged sediment for this project was collected from the second deposit we showed before, which is smaller one, and the sludge they were collected from water treatment plants and industrial byproducts, which are rich in organic matter or carbon over the large area of Normandy and Paris. The process of firing, we mix the materials where they were sharpened and dried before being fired, cooled. So this is an example of the first sample of the first aggregates which were fired. and the operation makes the aggregates to be expanded, and the addition of sludge, which is very rich in organic matter, makes aggregates to be light, porous, and giving them thermal property and also acoustic properties. If we see here the material, the sediment samples which were collected to be mixed with sludge, they are almost rich in organic matter as regards to other soils. And for sludge samples, we see here that the organic matter can reach more than 80%. So it's a very rich material in organic matter. Also, in that samples collected from the wastewater plant in the Paris area. This diagram shows the distribution of the organic matter content in different samples of sludge. So we see that the values are very, very interesting, more than 40. So this kind of matter is predominantly amorphous. No, not so much quartz, presence of halite, high organic matter content. So it can be used for manufacturing, aggregate manufacturing. It can act as pore-forming agent or by organic combustion, reduces density of aggregates, enhances thermal porosity, and but also contained salt can affect the durability of such material. So before using the mixture and shaping it, we measure the plasticity of different mixture, and we see that sludge increases plasticity of mixtures, so it improves molding operation. The optimal plastic index for extrusion was found to be ranging between 15 and 25. The aggregate formulation, we made six formulations by mixing sediment and fine clay particles, which were coming from the exploration of excavated soil, and we measure for each mixture the shear strength in order to link the shear strength to the molding facility of this material as aggregates. So we used the vine apparatus to measure this values of shear strength, and we see that when the water content increases, the shear strength decreases consistently. The fired materials, there are three firing temperatures: 800, 900, and 1000 degrees, which show that the color can change because of oxidations and modifications of mineral phases in the material during fire. Okay, so I just finished my presentation, but this task of when we cannot manage sediments inland, how we can manage it at sea, because this idea started 10 years ago from North European ports, which started to investigate how we can keep the sediments in the bed, the seabed, and just remolding it, and ships can sail through this suspension. How they can sail through the suspension. So the instability and restriction to sea clamping so requires providing land disposal, but in many situations we cannot have any surface for this deposits inland, and because dredged sediments are very wet, and they need to be dewatered before using in any application. So we need a large area. So this issue is very challenging for especially for small ports. Clamping far from dredging sites, so transport costs, like in the situation where this area of this channel, or this waterway in the Seine River, the Seine estuary, in this place there is a large high silting effect, so we get large volumes of sediment, consolidated sediments. So this operation was made in 2009, 2008. So the sediment have to be dredged here and transported till to this area, to this deposit area, which is allowed by the regulations, by the administration. But this transport can be very cost effective. So the port authorities decide to manage this deposit, land deposit. So that's the first operation in Le Havre. So this operation makes to thinking about in-situ solution, which keeps out sediments. And if we cannot make this solution of keeping sediment in land deposits, so we have to keep it in sea, and managing it in the way that the navigation will not disturb it. That from that reflection, the nautical depth concept was made. It means that in each depth, the suspension can be at a fixed concentration where ships or vessels can sail without any more cost or any more degradation or any difficulty for their missions. So significance of maintaining the nautical depth, alternative solution in order to avoid marine deposit is this nautical depth concept. While navigation may be possible through remolded sediment, top layer of the siltation has low strength characteristics. Navigation can be possible without removing the material. Effect of microbial slime, this biologic effect must be investigated, but it's very important. We will show that the organic matter can affect the properties, the rheological properties of such material. So microbial slime can provide buoyancy, oxygenation effect, and that can maybe help to be the layer of suspension more easily navigable. So the parametric depth, the bed level determined by some material parameters like target strength or yield strength in rheological experience. So the question is how making sediments navigable by lowering the in-situ density, removing materials, dredging, and clamping in place, just disturbing the sediment structure in place. So this the behavior in muddy water can be investigated by in laboratory by rheological investigation, but in the field in sea it can be investigated by echo sounding results, frequency dependent. So the challenge now is to be able to monitor this layer of suspended sediment, because the available techniques, echo sounding techniques now, just monitor the consolidated bed of sediment. Which level has to be maintained, and where is the nautical depth? Nautical depth, it means for each concentration we can stop the this this nautical depth. So this question was investigated in lab using rheology. So we used two kinds of rheometers, barrel plate test and also concentric cylinder test, and stirrer also. Geometry was used to investigate such samples of mud. The last study was using this used this kind of geometry, the stirrer, which can remold continuously the sediment, because settling can affect the measurements. Here is an example of the testing protocol, and the results of shear stress versus the shear rate, showing the yield stress in here, and the viscosity. So the viscosity seems constant for low shear rate, and then increases when the shear rate increases. Decreases to zero when the shear rate increases. So from that investigation, the study, when we used 4 sediments, different sediments collected from the first operation, when we start making bricks with the sediments. So the point P3 is the coarser sediment P3, and P18 seems to be the finest sediment. So this in this data from rheology tests, we show that the shear stress of sediment P3 was the higher one. So because when we also investigated the plasticity of such materials, this one, the P3, shows the higher plasticity and also the higher yield stress. High plasticity sediment can provide higher yield stress, more pronounced shear thinning behavior, Organic matter further modifies sedimentology by enhancing particle aggregation and structural complexity. The yield stress and shear thinning characteristics are particularly relevant indicators of shipment interaction. And in this kind of study, the organic matter is quite the same, similar for these 4 samples, but because of this plasticity of sample P3 and because of coarse grains of this sample, the yield stress was more important. In this another study of the rheological behavior of sediments from the port of Havre, where we show that for different situation, the shear thinning before rest and after rest. So in different conditions, the rheological response of such material is different, and we see here that the viscosity was decreasing when the water content increases, and this kind of material can show a thinning characteristics during test. Okay, I finish by summarizing all the results I showed below. That great volumes of sediments are dredged over the world, and their dumping at sea is no longer sustainable. Solution ashore must be extensively used for ultimately make durable materials from sediment and save natural deposits. We're considering what wastes actually are raw soils. So many excavated soils, many dredged sediments cannot be considered as wastes. Dredged sediments are still underrated due to regulations. The regulations are very severe toward this kind of materials. In parallel, remediation techniques have to be effective and sustainable to meet the regulations and reduce costs. So now I think from this year, from last year, the regulations, the European regulations for making sediments in land deposit are changing, and I think there will be more and more land deposit of such material. Beneficial use of sediment is effective for construction materials, brick and aggregates, and can be extended to reconstruct degraded soils, as we showed. Local use of dredged sediment in agricultural area is an environmental challenge, and the solution at sea by the concept of nautical depth can be investigated to reduce the volumes to be dredged, enhancing waterway maintenance and saving the marine environment. Thank you for your attention. This is part of our team in the first project for making bricks. And just I just mention for this conference, which will be held the next September in our university in collaboration with the Technical University of Delft in the Netherlands, about the mud net or fine-grained sediments. Thank you.